Alright, welcome to Lesson 6 in Unit 1 on Arithmetic Series. You'll be happy to know this is the last video in this chapter and this is the last lesson in this chapter. You may be disappointed to know that means chapter test coming up. Our objective in this lesson is, right here, to find the sum of an arithmetic series and to write an arithmetic series in summation notation. Here's our vocabulary in this lesson, and not as much as it was last time. So write this down, and we'll be using these terms in the video and in class. So pause the video and write them down. Alright, this is the formula you need to know for this section. It is the sum of a series formula. And it's right here. This is also on your reference sheet, so no need to memorize it. One thing to make note of. Let's see, your SN is your sum. Your N here is your number of terms. And minor mistake here. This is supposed to be A1. So it actually looks like this. SN equals N over 2. And it's A1 plus AN. A1 is your first term. AN is your last term. Alright, now our first example is we're going to find the sum of the arithmetic sequence 4 plus 9 plus 14 plus 19 plus 24 plus so forth until you get 2 plus 99. One thing you'll notice about the difference between an arithmetic series and a sequence is sequences have commas between the numbers. When we're doing a series, it's called addition and it has an end. Alright, one thing about this, we need to know our first number, which we do. That is 4. That's our A1. And we need to know our last number, which is 99. That's our AN. But we don't know how many numbers there are. So what we're going to do is we're going to use the arithmetic sequence formula. AN equals A1 plus N minus 1 times D. Find out how many numbers there are. And we're just going to use what information we have to plug into that formula. So what I'm looking for is my AN is 99, and I'm looking to see what position that number is. So it equals my first number, which is A1. And I don't know what number I'm looking for. That's my N. What position that 99 is in. And I'm going to multiply it by my common difference, which is 5. I'm constantly adding 5. So all I have to do is distribute my 5, take my 5, multiply it by 5n, take my 5, multiply it by -1. Then I'm going to combine my like terms. I have a 5n, no other n, so I just rewrite it. 4 minus 5 is -1. Then I'm going to solve this for n. I do this to get n by itself. I'm going to add 1. Which gives me 100 on this side and 5 in here. Now I've got to get rid of my multiplication of 5 by dividing. So that tells me 99 is my 20th term in that sequence. Now to find the sum, all I have to do is plug that information in. I have 99 is the 20th term, so I plug that in. And then I'm going to plug in my first number, which is 4, and my last number, which is 99. Now all I've got to do is do the math. 20 over 2 is 10, and 4 plus 99 is 103. So the sum of this series is going to be 1030. Alright, here's one for you to try. It wants to find what is the sum of the first even integers from 2 to 100. So how many integers are there from 2 to 100? And what are you constantly adding to get that next even integer? Alright, now here's something for you to think about. Question is, will the sum of a sequence of even numbers always be an even number? Will the sum of a sequence of odd numbers always be an odd number? Explain whether or not this is true or not true. Alright, this is summation notation, or aka sigma notation. Goes by either name. What we have is the Greek letter sigma, and what that means in math is we're going to sum it up or we're going to add everything up. So it's sort of what you would do with an arithmetic series. Here is the format of what it looks like. You have your sigma, and above it you're going to have an upper limit, and below it you're going to have a lower limit. Those are going to be numbers. And after the sigma notation goes the formula. To find the number of terms in a series when you have sigma notation, it is always your upper limit minus your lower limit plus 1. Alright, we're going to do this example together. What we have is we have an arithmetic series here, and we're going to write it in summation notation. This is what our summation notation looks like. So first of all, we have to find out how many numbers there are. So we're going to use our arithmetic sequence formula. So we're using this formula to find our n. So what we're going to do is we're going to plug this information in. We're going to plug in for an 207. We're looking for what number in the sequence 207 is. Then we're going to plug in our first number. We don't know what n is. That's what position 207 is in this sequence. And our common difference here, we are constantly adding 4 to each term to get the next one. Alright, so we distribute our 4. So we have 7 plus 4n minus 4. Then we're going to combine our like terms, 4n plus 3. Then we're going to get n by itself. We're going to get rid of our addition. And 204. And we're going to divide by 4. So that tells me that our n is 51. So when we do our summation notation, and I'm going to write it over here, this 51 is our upper limit. And we always start out with a lower limit of n equals 1. And that's the format you write the lower limit in. Your formula is this part right here. A sub n equals, it's after I substitute in. Your formula is going to have a variable in it, so it's going to have the n. This is my formula. After I substitute this in, and I forget about the 207 over here, that's basically a sub n. A sub n is my formula, and it's what goes after the sigma notation. So there is your sigma notation. Alright, here's one for you to try. Find the summation notation of the following series. One particular thing to take note of. This series is decreasing, so your difference is going to have what kind of sign? And here's something else I want you to think at. Look at the two previous examples with sigma notation. What were the summation, the formulas you inserted for each arithmetic series? I want you to think about these formulas and compare them to the slope-intercept form of a linear equation. Now, after that, I want you to consider this summation notation. And I want you to compare and contrast it with the formulas from the two previous examples. And we'll talk about it tomorrow.